Okay, we're gonna start before we get to lesson 3.4. What I would like you to do is pause the video and give this warm-up a try. What you're doing in this warm-up is you're trying to find what exponent would make this equation true. Okay, so once you've had a chance to try these questions, I'm going to go through and give you answers. So I'm asking you here, 2 to what power is equal to 32? That exponent would have to be a 5 to make that equation true. For 1/2 to be raised to a power to equal 2, obviously what's happening is you're flipping this number and then it's equal to a 2. And the only way to flip a number is if it was a negative exponent. So this would have to be to the -1 power. Basically the same thing is happening over here on number 3. 3 raised to a power, if you wanted to equal a fraction, basically you would have to flip the number, and only negative exponents allow you to flip numbers around. And then the last one, this is going from a whole number to a fraction, so we know that a negative exponent is involved again. However, the difference between question 2 and question 3 is that we're now going from 5 to 125. So in order to change the value itself, the exponent would not only have to be negative, but it would have to be a number other than 1. So you're going to think about like 5 to what power is equal to 125, and that is 3. Okay, we're going to finally start something that is a pre-calculus topic, and that is the topic of logarithms. So a logarithm is basically like an equivalent way of writing an exponential expression, okay? For example, the stuff that was on the last slide, 2 to the power of x is equal to 32. That is called an exponential expression, exponential equation. And a logarithm would be a way to write the inverse or the opposite of that, okay? So we're going to start by first trying to figure out the pattern and the way logarithms are written and what they mean. By the way, side note, when you read an equation that looks like this, you would read it as y equals log base b of x. That's how you would say it out loud. Okay. When you evaluate a logarithm, what you're doing is you're trying to figure out the value of an exponent. So if I ask you, what is log base 5 of 625? In your head, you need to be thinking about 5 to what power gives me 625? 5 to what power is equal to 625? And that number, that missing value, is what your logarithm is equal to, okay? So solving a logarithmic expression is the same as finding a missing exponent. We're going to practice a ton, so if it's still not making sense to you, that's totally normal. This is where we're going to practice, okay? So pay very close attention. If I ask you what is log base 2 of 32, in your head, you have to be thinking 2 to what power gives me 32? And it's totally fine if you need to use a calculator to help you with that. 2 to what power is equal to 32? 2 to the 5th power is equal to 32. That means that log base 2 of 32 is equal to 5. Okay, what is log base 3 of 27? You need to be thinking 3 to what power is equal to 27? And you can use a calculator to help you. 3 to the 3rd power is equal to 27, so log base 3 of 27 has to then be equal to 3. Okay, let's go down and do E next. Log base 3 of 1. You're going to think to yourself, 3 to what power is equal to 1? What's the exponent that makes everything be equal to 1? Do you remember? The exponent that makes everything be equal to 1 is 0. Okay, let's go down to F. Log base 2 of 2. In your head, you need to be thinking 2 to what power is equal to 2? 2 to the first power would be equal to 2. So this logarithm is equal to 1. Okay, let's look at, then we can go to D next. So for D, we're saying log base 10 of 1/100th. So that means we need to think about 10 to what power is equal to 1 over 100. This is kind of like the warm-up question, one of the warm-up questions we did. So remember that if you have a whole number and it turns into a fraction, a negative exponent must have been involved. So that means this answer is going to be negative something. And then if you have 10 and the number becomes 100, that would have to be squared to be 100. So negative 2 would be the power that would make 10 into 1/100th. Okay, last one, log base 4 of 2 is asking you 4 to what power is equal to 2. Okay, this one's the hardest because obviously we're not going from a whole number to a fraction. So this can't be a negative. But we are going from a number to a smaller number, which is not typical with exponents. Normally exponents make your answer bigger. So how do you go from a number to a smaller number? Well, think about like square rooting. Wouldn't the square root of 4 be equal to 2? And didn't we learn that square roots can be written as powers, fractional exponents? So 4 to the 1/2 power means the square root of 4, and that is equal to 2. So that means that this answer would be equal to 1/2 because that's the exponent that would make this statement true. Okay, calculators work for logarithms sometimes. Okay, so I want to warn you that you are not going to be able to rely on your calculator for everything with the logarithm content that we're learning. So like all this stuff back here, you can't type any of this into your calculator. The only things you can type into your calculator are things that have a common log. That means a log base 10. So if you have a calculator handy, or you can even use the one on your phone, you're going to notice that there's a button. There's a button that says log. That means logarithm. But there's no little tiny number written down here. When there is no number written, we can assume that it is a base 10. Okay, it's just kind of like a known thing. So if I ask you to use a calculator to type in or to evaluate log base 10 of 10, in your calculator, you would actually be typing the log button and then 10. And that is equal to 1. Okay, this second expression in a calculator, since it's a log base 10, you can do it. You would be doing 2 times log, and then I think it makes parentheses when you hit the log button, but log of 2.5. That's how you would type it into your calculator. And this one, just if you want to check, is supposed to be 0.796. Okay, this third example in your calculator, you would just type it as log parentheses -2. And you're actually going to get something that says error. The reason for that, and we'll talk more about this later, but the reason for that is if you're just thinking about logarithms, this right here means 10 to what power equals -2. It is impossible to raise something, to raise a positive number to a power and get a negative answer. It's impossible. So that's why we're saying that the answer is no solution, because this is not possible. Okay, let's stop and do a little bit of practice real quick. So what is log base 2 of 16? Remember, that means you're thinking 2, that's supposed to be a question mark. 2 to what power is 16? Okay, of course, again, you can use a calculator if you need it. The answer to that should be 4. Okay, Log base 4 of 1 over 64 means 4 to what power is equal to 1 over 64? Well, I know 4 to a negative power would make it into a fraction. And then 4 to something would equal 64. I think it's 4 to the third. So this would be -3. And then this last one is asking log base 5 of -2. So kind of like 5 to what power is equal to -2. Remember what we just discussed back here. It's impossible to raise a positive number to a power and get a negative result. So this is impossible. Impossible, there is no solution. Okay, there are a lot of logarithm properties. We're going to start by looking at some of the basic ones, okay? These properties just kind of help speed up the process of evaluating logarithms. Most of them you can kind of figure out based on what's given, but let me kind of simplify some of the more important things. Log base b of 1 is equal to 0. That's a statement that will always be true. The reason for that is because if you think about what a logarithm means, it means b to what power equals 1. Well, if the answer is 0, this means b to the 0 power equals 1, which is always true no matter what b is. Down here, if you see log base b of b to the power of x, what's going on here is you have two things that are inverses of each other, kind of canceling each other out. So a logarithm is the inverse of an exponential. That's what this is right here. So the log base b and the b cancel each other out, and they just leave you with whatever is up here. Same thing goes for property number 4 down here. So the b is raising everything to a power. So that's like your exponential, and then log base b cancels that out, leaving you with just this. Okay, let's just look at some examples. For example, the first example here on this page says log base 2 of x is equal to log base 2 of 3. Basically, your job is to say what x would be equal to. And I could use property number 5 to help me solve, because property number 5 says that if you have log with the same base on both sides, then the inside numbers have to be the same. So I have log base 2 and log base 2. That means the x has to be the same as the 3. And that, again, if you want to write it down, is property number 5. B, log base 4 of 4 equals x. So I want to figure out what this is equal to. You can use properties to help you, or you can just use logic, meaning like, let's solve this. This means 4 to what power equals 4? 4 to the first power equals 4. So I know that log base 4 of 4 is equal to 1. If you wanted to use a property, you could apply property number 2. You don't have to memorize these properties, by the way. They don't really have names like property number 1 or 2. It's just what I'm referring to in this notes lesson. Okay. The next thing we're going to do is we're going to work on rewriting things in exponential and logarithmic form. Okay. It's like a pattern. So here's how this works. Log base 25 of 5 is equal to 1/2. That's a given statement. Okay. Why is that? Well, that's because 25 to the 1/2 power is equal to 5, okay? That is all you have to do in this question is rewrite this expression as an exponential equation, okay? So I want you to kind of look at the pattern. This little base number here becomes the base of the exponential. Whatever it's equal to turns into the power, and the inside goes to the other side. Let's do it again over here. Log base 14 of 1 over 196 is equal to -2. That's a true statement. The reason this is true is because 14 to the -2nd power is equal to 1 over 196. Okay? That's all you have to do in this question is rewrite it as an exponential. Look at how things move. The base becomes the base. The fraction, the inside part, becomes the outside. And the equal to number becomes the power. For questions 3 and 4, you're going to do exactly what you did up here, but in reverse. You're going to start with the exponential, and you're going to write it as a logarithm. So if I know that 15 squared is 225, that means that log base 15 of 225 would be equal to 2. Look at how things move. They're moving in the same exact way as they did up here. The base became the base of the logarithm. Okay? The 225 went to the inside. The power became the equal to part. Okay, let's try again. 5 to the power of u is equal to v. That means if I write it as a logarithm, it would be log base 5 of the outside number, which is v, is equal to the exponent. Okay? 5 through 8, we're actually solving. So we're not rewriting the expression like we just did. We're going to solve the question. So this one says 3 log base 3 of 1 over 243. In my head, I'm thinking 3 to what power is equal to 1 over 243. Okay? I know it has to be a negative power because that's the only way to turn a number into a fraction is if a negative exponent is involved. And then I need to raise it to a power, a higher number because I need 3 to turn into 243. I believe 3 to the 5th power is 243. So then 3 to the negative 5th power would be 1 over 243. Log base 2 of 1/8. This means 2 to what power is equal to 1 over 8? Same thing as over here. It's got to be a negative because it turned into a fraction. And 2 to what power is 8? I believe 2 to the 3rd power is 8. Solve each equation. All right. Log base 8 of r is equal to 0. This is kind of hard to solve if you're just thinking about it in terms of what's shown. But let's think about what we know about logarithms. Okay, so kind of the way that we rewrote the logarithms on the first 4 examples here. Let's write it as 8 to this number out here, that must be the power, is equal to the inside number. And let's solve a little further. What is 8 to the 0 power? Isn't that 1? So that means r must be 1. Okay, on this last example, remember that if there's no logarithm, no base given, we can automatically assume that that is a base 10. So I'm going to read this one the same way I read number 7. I'm going to read it as this means 10 to the outside number would be my power of 4 is equal to the inside, which is r. And then I can solve this. What is 10 to the 4th power? I think it would be 10,000. It would be 1 with 4 zeros if it's to the 4th power. So that means r is equal to 10,000.